This is section 5.2, part A, probability models. Let's start with a very simple chance process, tossing a coin. When you toss a coin, we can't know the outcome in advance. What do we know? We are willing to say that the outcome will be either heads or tails. We believe that each of these outcomes has a probability of 1/2. This description of our coin tossing has two parts. First, it has a list of possible outcomes, or the sample space S, and a probability for each outcome. Such a description is the basis for a probability model. The sample space S of any chance process is the set of all possible outcomes. A probability model is a description of some chance process that consists of two parts, a sample space and the probability of each outcome. A sample space can be very simple or very complex. When we are tossing a coin, we can write the sample space using our set notation as S, our sample space, is equal to the set containing heads and tails. When Gallup draws a random sample of 1,523 adults and asks a survey question, the sample space contains all possible set of responses from the 1,523 of the 235 million adults in the country. This S, or this sample space, is extremely large. So many board games involve rolling dice. Imagine rolling two fair dice that are six-sided, one that is red and one that is green. Give a probability model for this chance process. So first we have to come up with our sample space. Our red die can be any number from 1 through 6, and our green die can also be any number from 1 through 6. Since there are two different die and each of them have a 6 sides, 6 times 6 tells us there's going to be 36 different possible outcomes. And our sample space will look like this. So these 36 outcomes make up the sample space S. If the dice are perfectly balanced, all 36 outcomes are equally likely. So each outcome has a probability of 1 out of 36. A probability model does more than just assign a probability to each outcome. It allows us to find the probability of any collection of outcomes, which we call an event. So an event is a collection of outcomes from some chance process. That is, an event is a subset of the sample space. Events are usually designated by capital letters such as A, B, C, and so on. If event A, written as the probability or as P of A, if the dice rolling example, suppose that we define event A as the sum is 5. So what's the probability of event A? There are 4 different outcomes that are possible for this event. So if we go back up to our whole sample space, it's possible that we can get a sum of 5 by getting a 4 and a 1, a 3 and a 2 and a 3, or a 1 and a 4. So out of all 36 possibilities, only 4 of them will give us a sum of 5. So since each one of them has a probability of 1 out of 36, and there are 4 combinations, the probability of getting a sum of 5 would be 4 out of 36. So our basic rules of probability, the probability of an event is a number between 0 and 1. All possible outcomes together must have probabilities whose sum is 1. If all outcomes in the sample space are equally likely, the probability that event A occurs can be found using the formula P of A equals the number of outcomes corresponding to event A over the total number of outcomes in our sample space. The probability that an event does not occur is 1 minus the probability that it does occur. We refer to this event of not A as the complement of A, and we write that as A with a little c above it, so it's the complement of A. If two events have no outcomes in common, the probability that one or either of those occur is the sum of the two individual probabilities. When two events have no outcomes in common, we call them mutually exclusive or disjoint events. For any event A, the probability of A is either greater than or equal to 0 or less than or equal to 1. If S is the sample space in a probability model, then the probability of the sample space will always equal 1. In the case of equally likely outcomes, the probability of A is equal to the number of outcomes corresponding to event A over the total number of outcomes in the sample space. To find the complement, we just do 1 minus the probability of the original event. And we can use the addition rule for mutually exclusive events, which means if A and B are mutually exclusive, which means they have nothing that happens in both events, then the probability of A or B is just the probability of A plus the probability of B. Distance learning courses are rapidly gaining popularity among college students. Randomly select an undergraduate student who is taking a distance learning course for credit and record the student's age. Here's the probability model. So the probability that the student is between 18 and 23 is 57%, between 24 and 29 is 17%, between 30 and 39 is 14%, and 40 and over is 12%. Show that this is a legitimate probability model. So in this example, the probability of each outcome is a number between 0 and 1, and if we add all these probabilities together, you will get 1, so this is a legitimate probability model. Find the probability that the chosen student is not in the traditional college age of 18 to 23. Now there are two different ways we can find this, because we're looking for the probability that it is not A, or the group that is 18 to 23. We can do 1 minus the probability of that event, and we would get 0.43. Since we do know all the other probabilities, you also could just add these probabilities together, and you would still get 43%. So there's a 43% chance that the distance learning student is not of the traditional college age of 18 to 23. Choose an American adult at random. Define two events. Event A is the person has a cholesterol level of 240 milligrams per deciliter or above. And event B is the person has a cholesterol level of 200 to 239 milligrams per deciliter. According to the American Heart Association, the probability of event A is 0.16 and the probability of event B is 0.29. Explain why these events A and B are mutually exclusive. It is not possible that one person has a cholesterol that is between 200 and 239 and a blood cholesterol level that is also 240 or above. Since a person cannot be in both groups, these are mutually exclusive events. Say in plain language what the event A or B is, and then what is that probability. So a person has either a cholesterol level of 240 or above, or the person has a cholesterol level that is between 200 and 239 if they are in events A or B. To find this probability, because these are mutually exclusive events, we can just add the two probabilities together, and we can say the probability of event A plus the probability of event B is 0.16 plus 0.29, which is 0.45 or 45% chance that they are an A or B. If C is the event that a person is chosen has a normal cholesterol, which means they are below 200, what is the probability of event C? So the probability of event C is just 1 minus the probability that they're not in A or B. We know that they could be in A or B 45% of the time, so 1 minus that will tell us what's remaining for a normal cholesterol level, which is 55%.